Are you ready to cook up some chemistry?
Let's get it! Alrighty, here are some of the equations for pressure. Now we got this one, which is P, which is pressure, is equal to N, which is moles, R, which is always 0.0821, times temperature, which is in Kelvin, all over V, which is volume. And then also to explain pressure and the motion of particles, as temperature increases, the pressure will increase. This is because energy is added, and as it is added, the particles will move faster, which expands the container.
And the units for temperature is degrees Celsius and kelvins, and how you convert degrees Celsius to kelvins is just add 273. And the units for pressure are 1 atm, which is equal to 760 millimeters of mercury, which is equal to 101.1 kilopascals. And we're back from commercial break.
This is Cade and Nate.
And we're going to be cooking up some Boyle's Law. For this experiment, we are taking a syringe and a balloon. You blow up the balloon just enough so it could fit in the syringe. And then you put the syringe back together.
And then you want to put your finger at the bottom of it so air cannot escape. And then as you push down, the volume of the balloon decreases. This is because all the air particles trapped in here are pushing against the balloon, which decreases the volume. If I take my finger off the bottom, it returns to normal size. No pressure and all that. Now if I keep the syringe down, where the balloon is, I keep my finger on it, and I pull, the balloon will expand. This is because the pressure is less, which allows the volume to increase. And this, for some reason,
it's because as volume increases, pressure decreases, and as pressure increases, volume decreases.
And this is Boyle's Law.
And we're back again!
Alrighty, cooking up some Chem.
Yes.
Now here we got some Lusak's Law. Alright, we're gonna cook some Lusak's Law. Now here, what we have is we have some water in a pan. We got the quarters in here, so this doesn't float. We got some candles, we got some food coloring. Now, we're gonna add some food coloring so you can see it better. Alrighty. Then, we're gonna place the candles in the center of the water. Alrighty, and then we're gonna light them. Alrighty, and then we're gonna place a plastic container right over them.
And as the flames are going on, they're using the oxygen in the container, which is making the temperature higher and also increasing the pressure with it. And as they go out, the temperature starts going down and the pressure also decreases. So the pressure inside the container wants to be the same as the outside area around it, so it starts sucking up the water.
And this is why in Lusak's Law, as the temperature increases, the pressure will increase, and vice versa. If the temperature decreases, the pressure decreases.
Yeah. Alright, we're back with our final experiment, cooking with Chem.
We're cooking up some Charles Law.
Alright, let's go. For this experiment, we're going to use a bottle and some boiling water. We're going to take some of the boiling water, put it in there. It's enough, right? That's good. That's good. Then we're going to put the bottle in the boiling water, takes the balloon, put it over the top.
See? So, as the temperature increases for the water, the air particles inside of it are going to start to expand. This is because energy is added. It's going to keep expanding, expanding. As you can see here, the balloon is starting to expand. It will take a little bit, but eventually it'll expand. See here, it's expanding. It's going to keep expanding. Like I said, as temperature increases for the water, it's just going to keep move. Their particles are going to get farther and farther apart. Now, if we take it out of there and we place it in the ice cold water, the temperature decreases, which decreases the volume. And the air particles are getting closer and closer together. So you can see here, the balloon is getting smaller and smaller. That's because the air particles are getting sucked in back into the container, and the balloon will eventually start to get sucked in to the container. This is because in Charles' law, as temperature increases, volume increases, and vice versa. When temperature decreases, volume will decrease, and that's Charles' law.
That was Cooking with Chem, cooking up Boyle's Law, Charles' Law, and Lusak's Law.
And as always, cooking with Cade and Nate.
Yeah.